Hello, hello. I hope everyone's doing well, having a good day or night wherever you are. This is my second video in this devlog recording for this game I'm making using next.js and Payload. A game I'm calling Muddy just for short right now because it's based off of the old traditional multi-user dungeons back in the 90s, 80s and 90s. And yeah, I'm just going forward, seeing how far I can go and seeing if we can have a little fun with it. You might notice this floating little helmet looking thing in the lower right. I'm just experimenting with using a VRModel to overlay on these videos to see if it makes it more interesting or not. And as with everything in this video series, it's all a work in progress. So you're just seeing a model with no texture or anything like that. So yeah, that's it about that. I tried using, so I'm starting to use OBS, and then I used animes to kind of do the face tracking and model management for expressions and stuff, which I don't have any expressions yet, but it's cool to use. And that's why you see that little, I don't know if you noticed, but there's like a little bitty watermark kind of appearing around this, yeah, there it is right up there. That's because I'm using the free version. But yeah, it's nice to just get up and running really quickly just to see how it works. And I use Blender to make the model itself. I installed a VRModel plugin to Blender to be able to create that initial skeletal mesh. What do they call it? It's an animated bone body, basically. So yeah, I used that, attached it to the right parents, and got a head moving. Pretty cool. So anyway, back to the code. Mostly focused on. So my goal this round was to see if I can't get a that classic terminal output that you get when you do actions inside of a MUD. And to do that, I found that I was trying to do a lot of things in a very unusual way. I guess it's difficult way, not necessarily unusual, but so when I installed Redux on my application, it introduced the concept of slices to me, and I noticed that slices seem to be a good idea for grouping together like specific parts of my game. In terms of state, but then I realized later on that just like being able to use it all in one single game store made a lot more sense because I'm wanting to use the different categories of data. For instance, I have player data versus zone data versus the actual terminal on the screen, and I found myself trying to connect these two a lot, and then eventually these two would have to connect over here for whenever the user moves in the world. So what I found was you would have to go to the component level to connect these two states or more states to be able to say, hey, for instance, I want to move the player in the zone and then output to the terminal, doing these three things at the component level, passing those states back and forth to get things to update was very cumbersome and just unwieldy. So what I've done is I've just combined them into the same state this time around. It was a good refactor, and going back and forth between those states really helps a lot. So here's an example of how I handle movement. So it takes in a game state. So I have these actions to these reducers to go north, south, east, west, up, and down. I pass the state to those, and then I supply the direction. This is a direction enum, I believe, yeah. And it just contains a bunch of different directions that I want to define, basically. So those get passed to this method. This method gets this current cell state because the player has its own coordinates, but it doesn't have knowledge of the whole entire map at the same time. So gets cell, takes the state, and then the player's current position returns that individual cell. And I use it later in this process here. And then I adjust the coordinate in this method here, and all it's doing is saying, hey, does this cell have a connection to another cell? And if it does, go ahead and adjust the coordinates appropriately according to the direction passed in. And if not, it returns false, and if it gets through here just fine, it returns true. And that's how I know that the player was able to move at all. And then if they did get to move, I just get the new cell that they're in, and I use that cell for the rest of these processes. So what I'm doing here basically is I'm just adding terminal lines. So basically when I move, I go to an array of an object of move messages based on the direction I've gone so that I can map what the message should be. As you can see, that's just passing in a string here. And then something interesting that I wanted to share here is that I'm doing a RichText terminal line. That's what RT stands for. So here, if the cell has a detail message assigned to it, what it'll do is, actually I just realized I can move this and not have to have a duplicate line. Anyway, it'll check if it's there, and if so, it'll add that terminal line in RichText mode essentially. And then it'll be something that the component has to be aware of. Is this RichText? Is this just a string to add to the terminal? So in the long run, it's all going to be RichText because there's going to be different colors, different boldings and all that. But just for quick messages, add terminal lines is fine. For not so quick messages that are like RichText oriented, I use this one. And then from there, I make sure that the viewport cells gets updated. Get viewport cells, what it does is it grabs a full grid, a 9x9 grid and a padded grid outside of that to throw into the user map so that you can get an update as to what the map looks like around you now that you've moved. And then if you didn't get to adjust because you didn't have a path, it'll just tell you, hey, you can't go in that direction. So that's the basic idea of how that works. So I wanted to show you how I'm using add terminal line. So here, all it's doing is pushing to a array of lines, right? And at some point, I'll probably limit the amount of lines at a time. But for now, I just let it be infinite for now. And then if it's a RichText line, I just pass an array. So it's either a string or an array. And then I just, in case there might be different texts in the future, I just make the first argument the type of line it is, and then the line itself. Now, what's neat that I wanted to show you over here on the right is that in my zone definition, I have a detail node that's in this guy right here, that cell. So it's at that position. And as you can see here, this is my old way of doing it, and I'm going to be removing this soon. The new way is to use what I'm doing here. So what I'm doing here is I'm using Payload's RichText field, and I'm creating custom leaves. These are called leaves because all they do is kind of format text without making a new a block line. So like if you did an H1, it would be a hard line return, whereas these just modify existing text within divs essentially. So these are like your typical leaves. I think code block might be different. Actually, it's not. I think it's a leaf too. So I had these just in case I wanted to use these, but then there's also what I'm referring to as my common conventions. Traversal is yellow. Any actions you take are purple, I believe. Beneficial would be green. Harmful, red. Speech is cyan, and uncommon is blue, I believe. So if I were to say unusual, that should be blue. Yeah, cool. So yeah, as you can see, it works pretty nicely. I can go ahead and save, make sure that that's in there. And what's cool about that is I'll show you how it's made. So we'll close next, we'll open Payload. And I've just set up a block that holds the CellMod connection. And here what I'm doing is I'm pulling in a RichText field. And I realize this is the wrong one. Here we go. That's it, yeah. So I have a import that holds all the leaves I want to configure for this RichText field. And I'm using just the basic RichText field. And I'm adding the leaves I care about, because you can add the leaves. I don't want to care about any of the elements because I don't need like block level stuff kind of taking up a lot of space in my terminal. I just want lines, and I just want those lines to be formatted. So all I care about are leaves in this case. So bold, italic, strike through, underline, code. And then I spread the terminal text leaves. And those are defined here. So as you can see, all the actions I've defined before split into different components. And each component looks roughly like this. So you use React, and you pull in the leaf button from the Payload component's RichText component. I import the CSS, and all it's doing here is just defining the class color. That's what actually shows up here. And then you make your button, and this could be an icon that you pull in, for instance, but I just wanted to be clear about what I wanted. Maybe at some point I'll just make it colored instead of texted. And one key thing to note, though, is that you'll notice that I have this name variable. This has to match the leaf property that's coming in. So if it's uncommon, you got to make sure that these just match up name-wise. So TT uncommon is for here and for here. And it'll check that property when it goes to render and render the right markup that you want to go with. And then the convention of slate.js, which is the rich text editor that Payload is using. You have to spread your attributes to make sure that everything is passed through in a nested fashion. And then I just add a class name to assign the styles to for payload purposes. And then any children would just go inside that. So if I nest another thing inside of this node, it'll just output properly. And then if it's not, doesn't match, we just do a normal node. I'm not sure if this is actually needed. I saw it in an example, and I just kept it. I think there's a more appropriate way to write this, but I just kept it all in one file because it was just easier for me to read, and these don't do very much, so I didn't think a complex hierarchy was necessary. And yeah, so a leaf is defined by its name, which you have here, which also matches the format in leaf. The button itself, and then the leaf itself, and then that's what you actually put into a leaf definition for it to know how to handle it in the actual rendering. And these all just follow that same convention, traversal, and they just have a different color. They all look the same. So that's what produces this, and that's what produces this. And one unique thing about slate.js is that it's a text editor that stores your text in a JSON format so that you can transpose it into any type of, or serialize it into any type of output you would like. So in my case, I actually have a way of processing that here. So I have a rich text example, but this is the main one I'm using. So this is a component that takes any nodes. So I loop through all the blocks, which is basically every output item here. Let me see if that gets passed in. Yeah, so each block is an array of nodes. And those array of nodes can have type value. It just has this structure, and then there could be sub-nodes under that. So it's a nested tree that can get confusing to work with if you're not familiar with recursion. Even if you are familiar with recursion, I'm sure it's confusing. Maybe I'm just not good at it either. I'm not sure. I always find it hard. So what I ended up doing was setting up this function to render a node. And then I made sure to pass the properties of that node that came in to the subnode. And what I do is I just make sure that there's a default of type text, because some nodes don't have a type. And I just kind of default to text because I can handle the extra cases later on in the process. I also check to see if the node type doesn't exist so that you know to put it into this folder. So right now there's only one node, the text node. And it'll just loop and nest if it needs to. So it grabs the component that is defined in the nodes array. This nodes array looks like this. Right now, as I mentioned before, there's only text. And then text, what it does is it's got a certain convention to follow. Any other node would follow this convention. And I just pull out the values from the node, and I have some defaults just in case they're not there. And then I update the class name to match the properties that come in. So if I highlight with traversal, it adds the traversal to the class, and then I have styles for all the different colors. And then I just map the next thing, and I render the next node under that, and that render node is the same one being pulled from this method. So that's how I'm accomplishing the recursion. I'm just pulling in the same method, but calling it in a subchild, and it works. But does it work? I'll show you in a second. Another way to look at this is with this rich text example. As you can see, I'm just marking up content using your typical formatting options, and including text, which means it also takes care of the normal output options. And yeah, same basic idea. just repeated multiple times in different components. And you can imagine that it would be easy to, for instance, create a new element. Elements and leaves kind of are structured similarly, except that with leaf, you create a leaf element from that import, or you make an element from that same package that I'm importing in on the payload side. And it all renders with this. So that's the rich text portion for when I'm actually outputting components. Now, let me just take a look at my notes, see where I'm at. Oh yeah, I wanted to show you the payload output. So when I save, let me make this a little bit bigger. All right. When I actually save to the database, as you can see, it's got my compiled map like I mentioned in my first video, how I produced this. Each cell in this map is produced here or defined here. And then eventually I'll get to the spawner I defined, which is an overlay. And here, the detail block type is overlaid on one of the cells. It gives you the old description, and then it gives you the TT description. The terminal text is what I meant. And as you can see, it's an array of nodes, which has children, and those can be of type text. Oh, here we go. Yeah, terminal text uncommon. Since it's a leaf, it just says if it's there or not, just like these three. So the first word U has these formatting options added to it. So as I loop through, I go here and I apply these styles and I make sure that it has what it needs. And it just goes through, and as you can see, you could take this and produce any type of markup you want or any kind of output you want, which is pretty cool. There's one application where I might actually have to use the injection of certain collection types, like for images, for instance, the upload type, or you might have a specific data type that's really nice to just be able to insert into your text editor. For instance, if you want to import like a link to a report from your reports collection or something like that, and you just determine what it does when it gets to that node, and you can pretty much just manage your content through here if you have a lot of flexibility and time to learn how Slate works. So that's the GraphQL side of things, and that's the payload side of things. So we'll hop over to the actual output window. So the output window is this black guy right here, this middle screen. And as you might have remembered on the mock, the bottom has like controls that are within reach of your thumb if we're on a phone. The top is like a view of where you are in the map, and in this middle will be messages that appear as you move throughout the world and do actions. So if I go south, you'll see that the map moves me south. If I go north, south, and it's telling me as I go, and as you can see, when I hit a wall, I'm unable to go in that direction. If I go west, there's no connection there. But if I go east, there's a connection. So it's doing a really good job at keeping up with the player. And if we go to the special area, this is a detail node, so it should show more information than what most cells will show. So if I go south, and there we go. It takes all the fonts that font stylings that I defined on payload and reapplies it here. And as you notice that there's one thing that's missing, the unusual nature. We went over here and changed it to blue, right? But I didn't refresh this page to get the updated zone definition. So if we refresh and we go back down to that zone, and now it's blue. I might not use blue because it's kind of hard to see. Maybe it's more for messages that are meant to be sneaky. I don't know. I'll play around with that, but that's pretty much it. Yeah, just looking at my notes, I think I covered everything. Yeah, I would just say having a lot of fun so far. The big lesson I learned is that don't split your store into slices unless you really want that hard separation between concepts in your application. Instead, rely on like importing what you need and spreading things out via your folder structure first. And if that's not enough, then yeah, create that separation. But it's definitely meant to be a hard separation between your components that rely on components to connect your store data. So yeah, I hope that was enjoyable to watch. I hope you're enjoying me going through and exploring this process and building this out. And maybe someday this will be a nice and fun game. So Thank you for watching. Have a good day. Bye-bye.